All right, 2.4 measures of variation. So the first one we're going to look at is range, but we've done range before. So what we do is we find the maximum point, maximum data point, that's the largest data point, and the minimum data point, which is the smallest data point, and we find the difference between the two. Okay, so for this problem, we have two pieces of data. We have two corporations, and they each hired 10 new graduates. So we have the starting salary in thousands of dollars for each graduate. So this first row is the starting salaries for Corporation A. The second one is starting salaries for Corporation B. Again, those are in thousands of dollars. And we want to find the range for each. So for the Corporation A, our largest salary looks like it's here at 47,000, and the smallest is over here at 37,000. So the range for Corporation A from with these 10 graduates would be $10,000. Now for B, the largest salary was 58,000, so I put 58 here, and the lowest salary was 23. So I have 58 minus 23. This is a much bigger range. This is 35 from the biggest number to the smallest number. Now don't be scared when you see all of these formulas. StatCrunch is going to do all the work. Whenever we see variance or standard deviation, we are definitely going to let StatCrunch do that work because it's very time consuming. But what we're going to look at is just a few vocabulary and symbols. So deviation would be the data item minus the mean, and we're going to work with that more as we go along. Then we have the population variance. So the population variance, we're going to use what's called a sigma. This is a lowercase sigma because remember the capital sigma looks like this, and that's summation. The lowercase sigma, which is again a Greek letter, is going to denote, well, if we have a square with it, it's going to denote the population variance. If we have the sigma down here, which is the square root of the sigma squared, that's going to be the population standard deviation. Okay, these are symbols we're going to use all semester. So the sigma squared up here, that is our population variance. The sigma here is the population standard deviation. And I'll show you as we have some data what those all mean. Okay, so we're again going to use StatCrunch. They gave us 10 pieces of data here. These are the numbers of regular season wins for 10 football teams in a given season. And they want to know the range, the mean, the variance, and the standard deviation. So we're going to click this box next to the data. The reason we do that is because that will bring the data into StatCrunch, and we don't have to type it all in. Once we get the data into StatCrunch, we're going to come up here to Stat, and then we're going to go to Summary Stat and Column. Okay, so we click the box next to the data. That brought all of our data in. Now we're going to go to Stat, Summary Stat, Column, and let's look at the next. Once we do that, we again have to tell us the StatCrunch where the variables are, where the data points are. So the data points are here in var1, which is that first column. So we're going to click on var1 here, and that moves it over to here. Now we want the range for this data. We also want the variance and the standard deviation. So we have to be really careful. If it's population data, then we're going to use what's called the unadjusted variance and the unadjusted standard deviation. So we will explain later in the semester why we use that word unadjusted. It's kind of hard right now to explain it, but if you have population data, you have to go down and find the unadjusted. If we have sample data, then we can just grab the variance and the standard deviation. I'll show you that in a few minutes. So then we hit At this point, it's going to give us everything that we need. It tells us the range is 13, the variance, the population variance sigma squared is 22.6, and the population standard deviation is 4.8. Right, so while we're here, let's talk about this a little bit. The variance and the standard deviation help us look at how much this data is spread out. Okay, so we have the mean. The mean is the average. If the data is symmetric, that's smack dab in the middle. Otherwise, maybe not. But we have that mean, but we have data points all over the place. So the variance and the standard deviation help us look at the spread of that data and how wide that data is and how many data points are away from the mean. Okay, so again, don't be scared. We are going to use StatCrunch, but again, we want to look at the symbols. So for sample variance, if we have a sample, not a population, then sample variance is going to be S squared and sample standard deviation is going to be S. Now, this is not memorizing because we're going to use these so much that they're going to be stuck in your head. But here's a nice table that shows us. So this, the first column is population, the second column is sample. With the variance, if it's a population, it's sigma squared. If it's a sample, it's S squared. For standard deviation, we have sigma for the population, S for the sample. For the mean, we have a mu for the population, and we have X bar for the sample. We use N for the sample size. The deviation, again, we're not going to, the StatCrunch is going to take care of these last two for us, but you can see that one has the mean, the population mean, the other one has the sample mean. In StatCrunch, we again have to be careful. For the population, we're going to use unadjusted in StatCrunch. For the sample, if we're using a sample, then we can just grab the variance and the standard deviation. We don't have to have that word unadjusted in front. All right, this lovely chart here is called the empirical rule. So this is a bell-shaped distribution. You can see it's symmetric. If I folded it over in the middle, the left-hand side would lay right on top of the right-hand side. So what happens with this, let's look at the number line first. So this number line, we have the mean in the middle, right? So with a symmetric curve, we're always going to have the mean in the middle. And then what's going to happen is we're going to add the standard deviation. So if we add the standard deviation once, we come to this tick mark. If we add the standard deviation again, we come to this tick mark. And then if we add it again, we go to this tick mark. Okay, so we're adding a standard deviation each time. On the left-hand side, we're subtracting the standard deviation. So we start at the mean, we subtract the standard deviation to go here, subtract again to go here, and subtract one more time to go here. Okay, so we're going to practice this. We're going to create number lines where we put the mean in the middle, and then we add the standard deviation on one side, and we subtract on the other side. But we're also going to use this area under the curve. So in that DSMA, where I told you I was trying to get you to look at area, that's what's happening here. So if I look at the area under the curve, so the area under the curve denotes all of the data points, right? So if I looked at just the area right here, okay, so all of this right here, that would be 34% of the whole area under the curve. If I look at this piece over here, that's also 34%. Okay, those are big chunks of data. So there's lots of data near the mean when we have a bell-shaped distribution, or what we call a normal distribution. So most of the data, because what is that, about 68%, is right next to the mean. It's here and it's here. As you go further out, you can see how tiny the area gets. So if you go that next step and just look at this area right here, that's only about 13.59%, that area. And then we go down to 2% for the area. And then we go down to this teeny little bar. And that's because we don't have a lot of data far from the mean, right? We are going to mostly have the data close to the mean. Okay, so we're going to look at this more. This is also on your resource sheet because we're going to need it for some problems. Okay, so we have in a survey conducted by the National Center for Health Statistics, the sample mean height of women in the United States ages 20 to 29 was 64.2. Okay, so the sample mean, X bar, is 64.2 with a sample standard deviation S of 2.9. Estimate the percent of women whose heights are between 58.4 and 64.2 inches. Okay, so I'm going to do a number line down here to show you where this number line came from. So the mean is always going to go in the middle. And for us here, the mean is 64.2. Okay, so the mean's always going to go in the middle, whether it's the population mean or the sample mean, it's going to go in the middle. Okay, and now let's start putting the standard deviation in there. So what we're going to do, this very next tick mark is going to be the 64.2 plus the standard deviation. So it's going to be plus the 2.9. So that's going to give me 67.1. Then I'm going to add 2.9 again. That's going to give me 70.0. And I'm going to add it one more time and get 72.9. Okay, that's how they got these numbers that are on the number line. Okay, so now let's go on the other side. So on the other side, again, I've got the 3 tick marks here. This time I'm going to subtract because I need to have smaller numbers over here. So I have 64.2. I'm going to subtract 2.9. That gets me 61.3. Subtract 2.9 again, I get 58.4. And one more time, I get 55.5. Okay, so just like any other number line, I'm going to add to head to the right. I'm going to subtract to head to the left. The mean is going to be in the middle. So 64.2, I added 2.9 each time as I headed this way. I subtracted 2.9 when I headed to the left. And remember, 2.9 is my standard deviation. That's going to show me my spread. So this is how they got the number line on the x-axis here. Now, let's look at what they're asking me. They said, okay, we want to know what's going on for the women between 58.4 inches and 64.2 inches. Well, 58.4 is right here, and 64.2 is right here. That means I need to know what all of this area is, right? These 2 blue pieces, I need to know what percentage those are, and then I will know the percent of women that are between those 2 heights. So if I use that chart that we saw on the last page, it shows me that 34.13 is sitting just in this blue right here, and then another 13.59 is sitting in the blue here. So if I add those 2 together, so if I add these 2 areas together, I get 47.72. So what that tells me is I have almost 48% of the women are going to lie between the 58.4 here and the 64.2. All right, so this is kind of messy, but this really is the same chart. It's just showing you that the 64.2 goes in the middle. On the right-hand side, we're going to add 2.9 each time. On the left-hand side, we're going to subtract 2.9 each time. I know it's kind of messy, but we'll get lots of practice with these. And then they wanted the area between 58.4 and 64.2.